In this lesson, we'll cover properties of logarithms. For our first property, we're going to start with this one here, log base b of a times b. If you have a product inside a logarithm, you are allowed to rewrite it as follows. Log base b of a plus log base b of b. So here a product can be rewritten as a sum. This is a very abstract looking rule, but I'd like to explain where it comes from by using exponents, or what it's trying to convey. So if you have something, maybe let's say 2 cubed, so the base is 2, and you multiply that to, let's say, 2 to the 4th. So here you're taking the product of two expressions, and the base is the same. The way you can simplify this is by saying, oh, well, I can add the two exponents together, and this is really, 2 to the 7th power. So this thing is really the same as this. Now, logarithms refer to what's happening within the exponent. So here we have a product, but it's really going to a sum. So while this is not a proof of this property, this is exactly what the property is trying to convey, a product going to a sum. Now let's try applying this property in example 1. Let's start with this one here. Log base 5 of 125 times x. So the product is, I'd say, 125 and x. And according to this rule, we can rewrite it as follows. This is really log base 5 of 125 added to log base 5 of x. And that's just a direct application of this property. We cannot simplify this anymore. This is log base 5 of x. But over here, I think we can simplify log base 5 of 125. I'm thinking off to the side, well, is there a number that when you put it into the exponent of 5, you get 125 back? And yes, the answer is 3. 5 to the power of 3 is 125. That means this whole thing is really 3. So completely simplified, this is 3 plus log base 5 of x. So this and this are equivalent. Let's try this here. Log base 9 of 9x. So just like the previous one, let's see, this is log base 9 of 9 plus log base 9 of x. So we're pretty close to being done here. I can't simplify this, but over here, log base 9 of 9, well, that's really 9 to the 1st. Log base 9 of 9 to the 1st is just 1. So I can replace that whole thing with, well, this is 1 plus log base 9 of x. Again, the reason for that is the way we got 1 was you take the base, you're asking what number do you put in the exponent so you get 9, and the answer here would be 1. And for this one here, this is really log base 10 of 0.01 times x times y. I think I have a product of two things, 0.01 and then xy. So I'm going to write this as log of 0.01 plus log of xy. And one thing to point out is, well, this is also a product. You can break this thing apart into a sum of two things as well. In fact, you could have done this as your first step. You could have said, all right, this is log of 0.01 plus log of x plus log of y. You can apply this rule as many times as necessary. If you had like 6 or 7 things inside of here being multiplied together, you could just write them out as a sum, and that'd be completely acceptable. The last thing is, what's log of 0.01? This is something that if you wanted to, you could check in a calculator, but that's going to be 10 to the negative 2 power. That's equal to 0.01. And the reason is it moved the decimal point 2 places. So I'm just going to replace this with a negative 2. And this means the final answer is negative 2 plus log of x plus log of y. The first property was for a product. What happens if you divide two expressions with inside a logarithm? Again, I'm first going to just state the rule, but then we'll describe where it comes from. It's very similar to the first, where you take log base b of a, but you don't add you subtract the term in the denominator like this, log base b of b. So it's a very similar looking rule, but we subtract, we don't add. So what's the reason for this? Like, why does this happen? So again, I'm going to use exponents to justify where this rule is coming from. So maybe I'll do something like maybe 2 to the 7th divided by 2 to the 5th. Properties of exponents tells us that when dividing, you can subtract the exponents. And this is the same thing as 2 squared. Subtracting because you're canceling 5 of these factors from 7 of these. 2 are left over. But the thing to take away is, here we're dividing expressions with a like base. Over here, we are subtracting the 2 exponents from each other. The logarithm is essentially the exponent. So with that justification, not a proof, let's try this in example 2. Let's simplify this. Log base 5 of x divided by 625. This is equal to log base 5 of x minus log base 5 of 625. And that's it, except, wait a minute, I think we can simplify this. Let's see. Is there a number that you can put into the exponent of 5 that gives you 625? Yes, that is 4. 5 to the 4th is 625. So the simplified answer here will be log base 5 of x minus 4. What about this one here? Log of 100,000 divided by y. Okay. Well, I could start by saying, well, this is log base 10 of 100,000 minus log of y. And this one's set up again, so, well, I think this is going to reduce to a number. What number would that be? Well, I see there's 5 zeros, so the answer is going to be 5. So this is 5 minus log of y. Again, the reason for that is the base of this logarithm is 10. And 10 to the 5th power means put 5 zeros after the 1. 1, 2, 3, 4, 5. There's one last property for logarithms in this lesson, but to justify it, let's look at example 3 here, where I want to simplify these two expressions. Okay, that first one, log base 5 of x squared. We do have a way to simplify this because you can really say that x squared is x times x. That's a product, which you can break apart into a sum, like this. And the thing to note is, because those are exactly the same, these two terms are exactly the same, we have like terms. You can say, well, we have 2 of these. There are 2 log base 5 of x's. I think something similar will happen for log base 9 of y cubed. Here, this one, well, this is really log base 9 of y cubed is y times y times y. And just directly applying that product rule, this is log base 9 of y plus log base 9 of y plus log base 9 of y. Same idea in the previous one, but we have 3 of them instead of just 2. So you could write this as 3 log base 9 of y. The big takeaway is that, okay, here we had an exponent of 2, and the number out in front here was a 2. Likewise, this was a cubed, and here that really just means we have a 3 out here. This trend continues forever. You know, had this number been 20, there would have been 20 of these things in a row, and the number 20 would have been out front instead of a 2. If you see log base b of something to a power, you are allowed to bring that power to the front of the logarithm. So it's like you're lifting it off, removing it, and placing it here. I'll write this as it's the power, whatever it is, times log base b of the expression. So not a proof, but a justification of where this thing comes from. Okay, so let's use that property 3 here in example 4. This thing here, I want to simplify log base 5 of x squared divided by 5. Well, for starters, I'm not allowed just to take this 2 and put it in front of the logarithm. The entire expression has to be raised to the power of 2, and this 2 only applies to what is happening within the numerator. So for this reason, we're first going to use that second property of, well, I have a fraction, so I can take the difference between the numerator and the denominator, like this. Okay, now here I have x squared. This 2 is completely attached to this x. I'm allowed to remove it from the logarithm, and this means I have 2 times log base 5 of x minus whatever log base 5 of 5 is. Well, that's log base 5 of 5 to the first. Therefore, log base 5 of 5 is just 1, and that's the simplified answer. Okay, for this one down here, log base 3 of the square root of x times y. The root symbol is kind of confusing. It might be nice to replace it with its equivalent exponent since we're talking about logarithms. This is log base 3 of, that's really xy all to the 1/2 power. Now here, this 1/2, unlike this 2 up in this example, this is completely attached to everything in this expression. You're allowed to start by removing it. So our first step can be to actually apply that third property. This is 1/2 log base 3 of xy. We can keep going. I see I have a product here. I can break it up into a sum. There's something to be careful about here, but let's go through it. I'll first write down the 1/2. And, I see a product. So this is log base 3 of x plus log base 3 of y. Now, I just did something wrong here. There's something incorrect about this. This is not the correct final answer. Like, what is it? Here's what it is. This 1/2 is being multiplied with this entire expression. There should be a 1/2 here. So just to put some parentheses for emphasis, it's really 1/2 times log base 3 of xy. That's really 1/2 times this thing. If you multiply the 1/2 into the parentheses, you get 1/2 log base 3 of x plus 1/2 log base 3 of y. And that's the answer.